All right, everybody. The first part of this video talks about why use radians instead of degrees, like why bother with radians whatsoever. We often use radians dealing with periodic functions because if we have a function that has an interesting shape and has a rather long cycle, which would mean a rather large period, the period being the horizontal length, if we find ourselves trying to describe this inside of degrees, maybe this is 90 degrees, this is 180, this is 270, this is 360. Every time we have a cycle go through, we might have the next cycle take us to 720 degrees. And then another cycle beyond that would be at 1080. And another cycle beyond that. And you get the idea. These numbers are going to get pretty big pretty quickly. The alternative is to use simply a smaller value. If 360 degrees is the same as 2 pi, or 180 degrees is the same as pi, then all of a sudden 720 degrees is just 4 pi, or this is 6 pi, or this next one would be 8 pi. We can simply describe the period or the degree in a different way, and it's much easier to manage. As for some specific vocabulary, let's talk about central angles first. A central angle is not a phrase we're going to use very often. Let's just be clear on what a central angle is. If you have a circle with the center point marked and it creates an angle, this angle right here is the central angle. As for the intercepted arc is the part of the circle, kind of like a line segment, but it's a curve. That's the part of the circle described by the central angle. And that's just going to be a length. Sometimes measured inches or centimeters or whatever unit we might use. That would be a length, not an angle. So the intercepted arc would be a length. The angle itself, this could be radians or degrees. This might just be something as simple as inches. So just so we're clear on what we're looking at. And then radians again, a radian is simply a different measurement of an angle.